Thank you, Christoph. So in the last hour, Christoph just gave a comprehensive overview of BCIs for those patients. And in this hour, I will. Okay, thank you. So in this hour, I will do a practical session to show how to use mindBEAGLE for assessment, communication, prediction, and registration. I will actually start with a few slides, then I will continue to the left demo. Okay, I hope you can see my slides. So I will start with a kind of use case of the mindBEAGLE system. As you can see here, the DOC patients are usually lying in bed, and most of them with eyes closed. So here we can use the EEG to measure the brain activity. Meanwhile, we can deliver the different types of stimuli, like the auditory stimuli while the headphones, or the tactile stimuli while the vibrostimulus. So the computer here, as you may see, receives and analyzes each data in real time and performs assessments using the BCI technologies, for example, based on the event-related potentials like shown here. If the assessment is successful, then we can even use mindBEAGLE to do communication by asking or answering yes/no questions. Since both the assessment and the communication reflects the brain functions of the patient, the mindBEAGLE can be used for prediction of the outcome of the patient. And as also mentioned, Christopher, when we repeat these stimuli over time, this may also help the patient to improve the functions. So this can also be used as kind of repetition purpose. Since not all the components are shown in the last slides here, at least the mindBEAGLE parts here. So in the middle, it's gelatinous, flexible. That's the EEG system we use to record the EEG data from the patient. It is a 16-channel EEG system which covers mostly the primary cortex and also part of the prefrontal and occipital regions. Meanwhile, we have the headphones that is used to deliver the auditory stimuli, and we have 7 vibrostimulus for the tactile stimuli. So they are divided into 3 bundles. The first and second bundle contain 2 vibrostimulus, while the third bundle contains 3. So all these 3 bundles are connected to the cube. As you can see here, there are 3 sockets here, which collects the vibrostimulus. So this cube basically integrates all the hardware components for running the mindBEAGLE, including, for example, the auditory box or the stim box that drive the auditory stimuli or the vibrotactile stimuli. It also includes FES. I'm not sure if you can see here. That's for the functional electrostimulator, and also TDCS. That's a transcranial direct current stimulator for muscle and brain stimulation for the future. So here it shows a kind of typical setup of the mindBEAGLE system. So both the mindBEAGLE laptop and the cube are plugged into the power socket, so which provides power supply. And there's a USB cable that connects the cube and the computer, so for communication control. The EEG system, or the gelatinous, is mounted on the patient, and data is transmitted wirelessly to the computer for analysis. On top of the EEG cap, the headphones are mounted and connect to the cube, which delivers the auditory stimuli to the patient. There are also 7 vibrostimulus connected to the patient. and also connected to the cube. So they're placed on different locations, usually like 2 on the wrist, 2 on the shoulder, 2 on the ankle, and 1 on the belly. So this location are chosen based on previous studies and experience. For example, usually the targets are on the wrist because the wrist has a good sensitivity of sensation, tactile sensation, and it also represents a large area in the brain cortex. The other tactiles are placed in like far away from each other, so they can provide a good spatial distribution. And so far, we implement the 6 paradigms in the mindBEAGLE: the auditory evoked potential, the AEP paradigm, and the vibrotactile paradigms with 2 stimulators, 3 stimulators, and 7 stimulators that are the VT2, VT3, and VT7. We also have the model imagery and the resting states. So as also explained by Chris before, in the auditory paradigm, we have the high tone and the low tones delivered to the patient, and the patient is instructed to like focus on the high tone and ignore the low tone. So for the VT2, it's kind of similar to the AEP because it also has 2 like stimuli, but it's in a tactile format. So the patient is instructed to focus on tactile stimuli and ignore the non-targets. The VT3 and VT7 is a little bit more comprehensive because it has more vibrostings, which means usually they have like more distractors. So for the VT3, we have 1 distractor, and for VT7, we have 5 distractors. And the model imagery is kind of similar to the recoverix. If you watched the video yesterday, so the patient is instructed to doing the model imagery of the left or right hand movements. For the resting states, so we just recorded the resting EEG for offline analysis. As you may notice, there are like some markers on each of the paradigm. I don't know if you can see it clearly. So for example, there is a small notebook mark here. This means this paradigm can be used for the assessment to assess the consciousness level of the patient. So you can see all these paradigms can be used for the assessment. The second marker is this check marker, which appears on the AEP and VT2 paradigm. So this means a quick test. So you can use the AEP and VT2 paradigm to do a fast assessment of the user, which is in real time. And for the VT3, VT7, and model imagery, there's a small token man here, which represents a communication function. So you can use this paradigm to ask yes/no questions and to communicate with patients when the assessment is successful. So later I will just show you briefly all these assessments and quick tests and communication running pages to give you an idea how it looks like. So the first running page is for the assessment. This is from the VT7 assessment, but basically all the assessment looks quite similar. So you can see first in the middle, that's the EEG scope. It displays the EEG signal in real time from all the 16 channels. On the right, this small brain map shows the locations of all these EEG electrons. In addition, it also serves as a quality indicator. If all signals are good, then nothing's showing here. But if one channel, for example, is getting noisy, then this channel marker will be marked in yellow, and then it will even turn to red if the signal a bit even worse. So on the left, this small stigma basically presents the patient setup. So if you see the headphones here, which means you need to put on the headphone on patients, and the headphone will deliver either the auditory stimuli or the auditory instructions to the patients. And for this big cycle, this green or this blue cycle presents the tactile stimulation. That's the target stimulation from the vibrostim. And these small black dots represents distracted or the non-targets from the vibrostim. On the bottom part here, you see these different waveforms. That's the event related potential or ERPs from the target or non-target or distractors stimuli. So, and in addition to that, you may also notice this green shadow here, which means there's a significant difference between the target and non-target ERPs. At the very bottom, I don't know if you see, this is kind of progress bar of this assessment run. So it shows the timing of the assessment. And this corner also matches with tactile stimuli. So for example, at the beginning, here, this green corner, which matches the green cycles here. So which means at the beginning, the target is on the left hand. And then it will change to the right hand, which matches the blue corner here. So for the quick test running page, it's a little bit different, especially the bottom part, although the upper part is basically the same. The EEG scope, the brain map with anecdotal locations and signal quality check. The stigma shows patient presentation, but for the bottom part, there's no ERP waveforms. Instead, it has kind of big moving bar here, which shows quick test results. So when you're doing the quick test, if each trial is classified correctly, then this bar will move from left towards right. And at the end, based on the final classification result, it will determine if the quick test is successful or not. And the last running page is from the communication. So as you can see here, the upper part still looks quite, let's say, the same. But the middle or bottom part looks a little bit more complicated. So here in the middle part, actually you can type a question here, communication, for example, do you like my talk today? I would assume the answer is yes, of course. Then I can click the green button here to start the communication. So the patient will be instructed to concentrate on the left if they want to answer yes, or concentrate on the right if they want to answer no. So eventually, the result also will be presented after the end of the communication. So there are additional 4 cycles here, which means there are like in total we can ask 5 questions as a group. That's also mentioned by Christoph. It's always better to repeat the communication for a few times so that we can be more sure the result is more reliable. At the end, so I give you a kind of summary of these paradigm durations. So as also explained by Chris before, we try our best to make these paradigms a bit shorter, so to make it more easy to catch the small window of the patients. As you know, the DOS patients are usually very tiring and easily fall asleep, so we need to make sure this duration is as short as possible. As you can see here, the AEP takes around 4 minutes. The VT2 and the VT3 is a little bit shorter, about 2.5 minutes, and the VT7 is like 3.5 minutes. Of course, the quick test or communication is much shorter. So the quick test for AEP is like 1.5 minutes. The other is like more about like 0.5 minutes. So before I go into the live demo, I also want to show you like an example of this results page. So let's say what we would expect from the results. So here is like more general results from the ERP, it's from the AEP paradigm, but basically the other ERP paradigms have them like more or less the same result page. So we have the ERP waveforms here. We can see the significance for example, here the P300 is significant, and also it's also significant on 100 here. And also this remap shows the amplitude of each channel. And in the middle, it's the accuracy plot, shows the accuracy changes according to the number of average. So when we have a larger number of average, of course, signal-to-noise ratio would be improved and accuracy would increase. So you can see here, it's say around after 10 accuracy, we can see the accuracy after 10 averages, we can see the accuracy is already about 95%. And the very bottom shows the history of data. So it's also important to repeat these mindBEAGLE measurements for, let's say, a few times on the same day or even a few days at different time. So that's why we can also see here at the beginning, for example, here the accuracy is very low. It's just 10–20%, which means nothing. And after we repeat this few times, we can see the improvements. That's also an idea that we need to repeat these mindBEAGLE sessions to catch the consciousness window from the patient. The similar thing is for the ERDS result. I'm not going to details here because you already noticed this from Chris' talk or also from yesterday the recovery sessions. So in principle, it shows the power changes at different frequency bands when the patient is performing left or right hand mode imagery. So okay, I'm going to move to the live demo, and I'm going to invite my colleague Vaishali, and I'm going also to stop the sharing. Please exit here, and I'm also going to change the camera so you can see. Yeah, so you can see clearly Vaishali is here. Okay. And before that, I also show you a little bit about the mindBEAGLE. So I think you can see it here, probably to the mindBEAGLE laptop. So here is the cube we have here on the headphones that's used to deliver the auditory stimuli. And I don't know if you see, yeah, probably you can see here that's vibrostimulus we use to deliver the vibrotactile stimulator. And of course, we have the EEG cap here. So I'm going to first, yeah, maybe it's better I start the mindBEAGLE first, and then I go to prepare the EEG cap. So yeah, here, since I already, for the main page, I already created a patient here. I will just go start with the auditory paradigm. And so here you can see the results from the last assessment. And here I'm going to start a new assessment. And here you can see the EEG scope. Of course, now it's just flat lines. Then I'm going to prepare the EEG. So I'm going to put on the EEG cap. Just a little bit. Keyboard. Get the positions correct. Oops. Don't make it right. It's better. And I'm going to ask you for a little bit in front, so to the eyes looks a little bit nicer. And also a little bit more comfortable. Good. Going to check out the reference. Some terminologies. Vaishali also had this very nice experience with mindBEAGLE. last winter, actually, she brought the mindBEAGLE system to India. I think that was the first mindBEAGLE assessment in India, I guess. So she also get very good results from the patients. These channels, you probably can see the EEG signal is changing. When I'm putting the gel on this channel, the signal should come out instead of 5 times. So you will take a couple of minutes. If you're experienced with preparing the EEG, so you should get the signal in a few minutes. The channels, just take a look at the signal quality. I think it looks great. You blinking eyes. Yeah. You can see also this when she's blinking the eyes, the signal is noise shown here, it marked as yellow. Could also bite. Yeah. And also move your head a little bit. Yeah, so sometimes you see when there's a artifact, it also marked here. So I think it looks good. Then I'm going to put on headphones. It's a little bit heavy. Actually, works better if I'm taking this lying on the bed. Yeah, we can put it on. So, it's okay, or should I? Yeah, it's okay, let's start a little bit. Okay. It's better? Okay. So let's see how the signal looks like right now, because there might be some interference from the headphone. Let me just double check. I think the C5 is a little bit worse, so I'll put a little bit more gel on C5. Just in case. I think around now it's acceptable. Just make sure. I think it's really perfect. Okay, so as I explained a little bit before, we have two tones, the high tone and the low tone. So can you hear? Great. So if you're ready, then we can start. Okay, so just count the number of the high tones while ignore the low tones. Okay, ready? Let's go. So try not to talk and move too much, because this may cause additional artifacts. This EP will take around 4 minutes. So it's about 1 minute left, and already see some waveforms, and also the significance area is marked in green shadow here. I'll just show you the earpiece from all channels. So you can see more than half of the channels we have a significance area. We have accuracy of 59. It's not perfect. I think Vashala is a bit nervous or it's getting distracted because I'm just working and talking for some additional. So if we look at the results page, we can see the accuracy actually is increasing when we have like a large number of averages. Which means the signal noise ratio might not be the best in this situation. That's why the accuracy, I mean, it's the accuracy is 59 and it's far above the chance level. And it's also significant results. So I can save the result here and also add the result to the history data. So all this data will be saved, and I can go to the results, the EEG paradigm again, and check the results here. So for example, here it shows the amplitude. So here the CPZ has an amplitude of 3.8 microvolt, and the C5 has a 7 microvolt. And from EPs, we can see here there's significant area here in the ERP between the target and non-targets. And we can also take a look at all channels. So you can see basically it's consistent on most of the midline channels. We could try a quick test. In this case, we'll see if this would work. And so we can start a quick test to run. So basically, quick test is just a short real-time assessment. Usually we do this when the accuracy is high. So still the high tones and the low tones. So every setup is the same. And we'll just try this one. It will be like 1.5 minutes. Shirley, you ready? Okay, so I will start with this one. Ready? And let's go. Here we have the progress bar here. So if the earpiece are classified correctly, we will see a moving bar at the bottom. So now it starts moving from the left towards the right. And we'll see how much this moving bar will achieve. Right. Great. Okay, so unfortunately the quick test was not successful, although you see the progress bar is moving towards almost right. But again, I think the signal to noise ratio is not perfect, and also accuracy is not very high in this case. So that's why it was not successful. I can also show you the case from the run we did a few days ago. So here is the runs from today, and we can also compare the results from like a few days ago. So we had a very successful assessment. Here you can see a very nice P300 with a accuracy of 95%. And for a quick test, we had a successful quick test here. So you can see that's when the accuracy, the assessment is successful, accuracy is high, it's more likely to get like a successful quick test. Okay, so given the time, I will not repeat the assessment, but I will move to the next paradigm, that's vibrotactile 2. So I will go to this paradigm, and I will first start again the assessment. So you can see they are like left and right wrists with tactile stimulators. So first, I'm going to place the tactile stimulators. So these two are the one related. So start to placing two vibrostings on the left and the right wrist. So I'm trying to put a little bit side, but first confirming if I had the wrong correct stimulators. So I'll first start with the left. So this one is the left. So I'm going to switch. I think it stays the same. So I will place thank you, Shani, for the help. And we'll fix the tactiles with the tape. That's also usually we do with the patient, because some patients do have lots of involuntary movements. So it's better to always to fix it with some tapes. Here, also fix the other one. Right. Right wrists. Use additional tape to fix it. Now it's good. Yep, I will just try the rubber sting one more time. So this is the right, and this is the left, and you will hear the instruction about the left wrist. Okay, great. So then we'll start with VT2 paradigm. So your target is on the left. Just count the number of vibrostings on the left wrist and ignore the other. Tell me how many times you counted after this session. So that's a challenging. Okay, ready? Okay, then let's go. Take 2.5 minutes. Okay, perfect. We got 100% accuracy.
60 gone.
Yeah, that's perfect. So we can also see the very beautiful evoked potentials here. So you can see here, the significance also marks exactly around 300 milliseconds. That's a perfect P300. And we can already see the accuracy plot. It already reaches 100%, I think, after 1 or 2 averages. So signal to noise ratio is perfect. We can also save this data and also add it to the historical data because we know this is very valuable data from Ashani. It's a great achievement. Although I'm talking and moving, but still got a very perfect accuracy. So we can go back to this VT2 paradigm and take a close look at the evoked potentials. So here is the evoked potential from CZ. As you see, it's basically out of the range. It's -5 to 5, and you see for her case, it's really great. And we see the maximum value here is 9.3 microvolt. So it's really great. And if we take a look at all the channels, so basically all the channels looks quite identical. You have large area of significance as marked by this green shadow here. Perfect. So take a look again. And then we can continue with a quick test. So for the quick test, as I explained before, basically the setup is exactly the same. So the task for Vaishali is still again to count the left wrist. That's a target stimuli and ignore the others. But of course, this time it will be shorter. So really needs to be fully concentrated so that we can get, again, the perfect accuracy. And okay, now we check again. I think all the signals looks great. And I think Vaishali is getting more relaxed compared to the beginning. So let's see if we can succeed this time for the quick test. Okay, ready? Okay, so we'll start the quick test, focusing on the left. Let's go. Great. So this time we succeeded. Perfect. So you can see again the results here. So this ERP plots is again great with a very large amplitude and a great area of significance. And it was tested successfully, so which means in real time, this short period of ERPs matches very well with assessment data. Great. So again, I will save it and I will add it to the history data. So since we still have a little bit time, I will also try the VT3 paradigm. So in this paradigm, we will add additional distractors. So now we have, again, the left and right. Let's try again if this is left or it is switched. Is this left? No, it's still left. Okay. Here is right. Okay, perfect. And then I add additional one for the ankle. So I will move to the other side. Okay, thank you. So we have lots of tactiles here. As I mentioned before, we have 7 tactiles. I need to choose the correct one for the ankle for this structure. So I'm going to just put in the socket on the left ankle. Okay. I'll just try to confirm again. So is it okay? So the left ankle, left wrist, and right wrist. So we also have the auditory instructions. Phone is not comfortable. Should I move a little bit? It's okay. Okay. Yeah, just let me know if I need to make some adjustments. And for the auditory instructions, we have the right wrist and then the left wrist. Okay, great. So everything is set up, and then we can start. So as I also mentioned a little bit before, for the running page, we need to change the focus from the right to the left. So the beginning, you need to count the vibration on the right. It will give you an auditory instruction, right wrist. And then after 1.5 minutes, you will switch to the left. You need to count on the left wrist. So as I also mentioned a little bit before, this task is relatively more complex compared to the VT2. So let's see how Vaishali will perform. Okay, so are you ready? Okay, so we'll start with the right. Let's go. Take again, 2.5 minutes. And now switch to the left. Okay, great. Again, 100% perfect. Great job, Vaishali. So we can see the very large amplitude of the earpiece. It's perfect. And also accuracy, you see, it really starts with a single trial is already above 90%. So it's really great earpiece. And here I will just save the data. It's perfect data. Of course, I need to save it and also add to the historical data. And I can continue. So I think I still have a few minutes. I will try maybe 1 or 2 communications, giving the very high accuracy in the VD3. So I believe we can achieve a good accuracy also in the communication. So we'll go to the communication. And this again, the setup is the same. Should not change, or we will not change anything. So this is right wrist, the left wrist, and the left ankle. So just confirm the setup. And by the way, we use the latest calibration file. That's 100% assessment we just did. We have a few from the previous one, but I think this one would be the best and the most recent one. So you can see here, it's a running page for the communication. So, I mean, we can type some questions here, and we could also ask questions. For example, Marshall, do you like the mindBEAGLE setup? Yeah, I would assume you're answering yes. So if that's the case, you should focus on the right wrist. That's the yes. And we can start. Ready? So count on the right, and let's go. Perfect. So you can see the results here. That's a yes. You see the count actually changes when each trial is classified correctly. So eventually the final decision is yes. So which means partially you do like the mindBEAGLE. Thank you. Yeah. I think I can still try maybe one more question. So we can try, for example, a low question. So for example, I'm speaking Chinese. We'll see how it looks like. So this time, if it's no, then you should count on the left. Okay, so you're ready? Let's count on the left. Let's go. Perfect. So great. So we see again, the color is changing to blue, which corresponds to the left side, and that's the low answer. Perfect. I think given the time, I will stop the session here. So I will still save the data. And so before I go to answer the questions, I can still show briefly there maybe the other paradigms, just showing it without really doing because of the time. So we have also VD7 paradigm here. So we have of course, assessments. So you see all the locations of all the vibrotactiles. And we have, again, instruction for left and right wrist. So basically, everything is kind of similar to the VD3, but we have a large number of distractors. And we also have the communication here for the VD7. So it's basically the same setup as the VD3. So you see all this running page here, as I also explained a little bit before. So you can start with the questions with also the VD7. And the last thing I want to show is the model imagery paradigm. So I hope you can still see it here. So the mode imagery paradigm, we have it here. So we also have the assessments and the communication. Of course, we first need to do the assessments, and we have the left and right wrist. That's the instruction for imagine the left and right hand movements. And we have a marker here. Actually, in addition to the mode imagery, we also have kind of precursor stimulation. So before the patient start to imagine left and right hand movement, we give a short turn of vibro stimulation to indicate which side they should imagine. That's kind of precursor. We call this, according to the previous study, will improve the accuracy of the mode imagery. Okay, so I will just stop the like the live demo here, and I will come back to the seat. So I will also let you release. I will change to let's say my camera, so I can maybe take a look. Okay.
So Ren, there's one question. Can you also use wet and dry EEG electrodes for the experiment?
We have not tried yet, but in principle, if you can, maintain with a good signal quality, I think the dry electrodes would also work, or the hybrid one, for example. If the signal is getting worse during the assessment, I think it's better to insert some gels so as to improve the signal quality. As you see, the current signal quality is very critical to get an accurate assessment or communication. So that's a very important part. We should always be careful.
Another one is, what is the best and easiest paradigm that you can use with DOC patients?
So according to our experience, probably the vibrotactile paradigm is relatively easier, especially the VT2 paradigm. Usually we also, the other reason is this VT2 paradigm has a very short time. So it's more likely to catch the small window of the patient, when they're awake or when they can pay attention to. On the other hand, this auditory paradigm or the mode imagery paradigm takes a little bit longer time. So it's likely some patients may get tired or fall asleep during the assessment. So that's also a reason, as was Chris mentioned, the mode imagery paradigm works the least so far, because it takes the longest time. It's also task is more challenging given the longer time.
Thank you very much, Ren and Vaishali, for the nice demo.
Yeah, thank you, Vaishali.
Thank you, Ren. Thank you.
Maybe it's also worth to mention that the whole mindBEAGLE system easily fits into a backpack, and then it's also possible to visit patients at home.